Hello. Today we are going to talk about energy storage and saltwater batteries and how they relate to renewable energy. To combat rising global temperatures, nations around the world have agreed to reduce their greenhouse gas emissions. Electricity generation currently makes up about 40% of emissions globally. To reach their targets, renewable energy sources are being invested in. However, they aren't yet capable of fully replacing traditional generation methods. To understand why, we need to know a little bit about the power grid. When you use power, that power is generated at the moment you use it. The grid must therefore be capable of supplying power at the exact moment it's needed. The problem with many renewable energies is that they are variable. That is, they can't produce power on demand. They can only provide power when energy sources like sunlight or wind are available. In the chart on the left, we can see the solar power output over the course of a day in California. Output varies with sunlight and cloud cover and ceases entirely when the sun sets. The chart on the right shows one day of wind power. Wind is even more variable than solar and is often unpredictable. These charts show the variability of wind and solar power over the course of 1 year. Each line on the chart represents one day. As can be seen, there is a wide variation in the peak power produced by solar, which is only available during the day. Wind production is also variable, and output can be completely unpredictable. The biggest problem with this variability is that power production often doesn't correspond to times of peak demand, and this is what makes renewables difficult to integrate within the grid. This graph shows the grid demand for one day in California over 5 years. As more solar panels were added to the system, the demand for electricity from the grid has fallen significantly during daylight hours. However, as the sun sets, we see a sharp increase in energy demand to levels similar to past years. What this reveals is that while an increase in renewables is able to reduce overall energy demand, it has had little effect on the overall capacity requirement from the grid. To moderate the issues associated with variable supply, we need a method of storing the excess energy produced by renewable sources, so it can be utilized later when demand increases. One common method of storing energy is through the use of batteries. All batteries essentially work the same. When you connect the two terminals, a chemical reaction creates a flow of electrons. The amount of energy it can provide depends on its energy density, which is determined by the types of materials used. It also depends on the size of the battery. The trade-off in all batteries is energy density versus size. Despite their prolific use, conventional chemical batteries have a number of issues. Lithium-ion batteries can explode violently if damaged, or if they develop an internal short circuit. Most conventional batteries are built using toxic metals such as mercury, lead, and lithium, which if disposed of incorrectly pose a significant threat to the environment. They are made with these toxic chemicals to increase the battery's energy density and decrease its size. Unlike most batteries, saltwater batteries are large and have a low energy density, but they are made with much safer and cheaper materials. Their electrolyte is a concentrated saline solution, which gives the battery its name. They are non-flammable and pose no risk of explosion even when punctured. They are primarily made from elements that are plentiful in nature. This means that they are both non-toxic as well as inexpensive and easy to source. These batteries have several limitations. Their peak power is significantly limited by their low energy density. Their efficiency is about 90%, which means you lose about 10% of the battery's energy to heat when you use it. This value varies with the speed that it's charged or discharged at. The saltwater electrolyte also limits the voltage of these batteries to around 2 volts. This means batteries must be connected in series to provide useful voltage. So what does this mean for you? If you're looking to reduce your carbon footprint and are considering incorporating renewable energy such as solar panels in your home, saltwater batteries can provide reliable energy storage to maximize the capability of your system while being safe enough to keep around your children and pets. Let's examine what this could look like. The following example shows the effect of incorporating a solar panel system into a residential home. The graphs show power supply and demand over the course of one day and 1 week. The total power demand for the home is shown in blue, and the power supplied by the solar panels is shown in red. The remaining residual load is shown in gray. It can be seen that the residual demand drops significantly every time the solar panel is used. However, when the power supplied by the solar panel exceeds the demand in blue, that excess power can't be used by the home. To recover this power, we can incorporate a battery storage system specified as shown. The graphs show that the battery charges every time the supply exceeds the demand in the previous example. The charge then decreases when the home uses this stored power. Over the week shown, the solar panel system saved the home 144 kilowatts of power with no battery, and 180 kilowatts of power with the battery. This means the battery increased power savings by 25%. Looking at data over a whole year, the battery and solar panel supplied the home with 11 megawatts of power. Based on the pricing scheme shown, this amounts to about $690 of savings per year. Energy storage will be required to incorporate clean renewable energy into the power grid. Saltwater batteries provide a safe and economic option for people seeking to do this in their homes. Moving forward, this technology could be scaled up for large power generation units, so long as space requirements can be met.